Degrees and radians are the two ways I measure angles. And I want to be able to converse in both languages. So at the end of this lesson, you will be able to A, use radian measure, B, use degree measure and convert between degree and radian measure, and C, use angles to model and solve real-life problems. Shall we begin? First of all, what is radian measure? I'm going to give you two definitions I hate, and then one definition I like. First definition. Take a unit circle. 1 radian is the measure of a central angle theta such that the ray intercepts the arc S equal in length to the radius of the circle. What does that mean in English? It means something. Yes, it does. I'm going to do red, and I'm going to do that. Man. I did pick red. Bam. I am angry. Okay. You won't like me when I'm angry. Okay, so I got a radian, or array right here, right? And I do an angle, let's say about there. Now, it's a unit circle, so what's my radius measure? 1. Why do I choose 1 for my radius measure? Makes my math easy. Yes. Okay, now, 1 radian gives me this angle theta right there, such that the length of this arc equals the length of the radius. That is a radian. Do you like that definition? I hate that definition. I hate it. But it makes sense, right? Makes sense? Okay, another definition of radian measure. The length of an arc, S, divided by the radius of the circle that produces that arc. I basically said the same thing. Okay? If I have a measure, let's say I'm going to go back now. Thump. Let's say, and one more. Let's say and let's say I go right there, right? And I say, well, this length here, we'll call S. And I divide it by the length of the radius, which is, in the unit circle, it's 1, right? That tells me how many radians I have. I basically take the same definition and reword it a little bit. So I don't like that one either. So now I am going to give you the definition I like. My definition. Radian measure is a measure of angles such that 2 pi is the same as 1 full revolution. Two pi is 1 full revolution. Now, as a consequence of that statement, therefore, how many degrees does 2 pi equal? 360. Good. 360. If you think about it another way, a radian measure is, it's a representation of circumference, right? So 1 full what's the circumference of the unit circle? 2? 2 pi, right? The circumference is 2 pi times the radius. Coincidence?
Yes.
Coincidence? No. No.
I think so.
I think not. All right. So, why do we like to use radians? You're going to love radians in calculus. You're going to love them in calculus because we got something in calculus called the chain rule. Chain rule makes me, if I got a function within a function, what we call a compound function or a composite function, right? If I got a composite function, I got to do an extra step when I'm differentiating. And something being in degrees is an extra function. So I always got, when I'm differentiating in degrees, I always got to do an extra step. In radians, I don't have to do that. So you'll love radians in calculus. Okay? But when we're converting from radians to degrees or vice versa, how many of you guys got two different equations to go from one direction or the other? How many of you guys don't remember? How many of you guys don't care? How many of you guys are even listening right now? Is this the zombie class? My God. My goodness, this is zombie class. Wake up, guys. We got trig going on, for Pete's sake. What would you rather be doing right now?
Dissecting isonomials.
All right, so before I go into conversions, let's talk about boundaries. Now, this is 0 degrees. It's also 0 radians, right? Which way do I measure positive angles? Who remembers that? Counterclockwise, or as the Brits say, not to the left. Not to the left, because here we're going right, aren't we? Yeah, well, no, we go counterclockwise.
I don't know.
Which way does the clock turn?
I realize.
Clock goes tick, 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 tick. It goes this way, right? So counterclockwise is the opposite way.
Okay.
Counterclockwise. All right, so all the way around is how many radians? How many radians? 2 pi. 2 pi. Okay, so what is this in radians? Huh? Half pi. Half pi. Right? How far around the circle is this?
1/4.
1/4, right? So I take the full circle, 2 pi over 1 times 1/4. And I get, well, 2 pi over 4, but I reduce that and I get pi over 2. That's how I get that. Well, let's go here first. Pi. Good. And then Morgan?
3 pi.
3 pi over 2. 3 pi over 2. Okay. Okay. I like where we're at right now. Some terminology before we go into conversion. The initial side of an angle is the side from which one is measuring. So, want to see what Henry showed me earlier today? I'm gonna draw my angle. Okay? Watch this. Look at that. I love it. Oh no. What? What happened?
A mess, apparently.
A hot mess. There we go. All right, now I got this. I'm going to put that right here. Oh, not quite. I got to turn it a little touch. Right? Oh my gosh. There we go.
Good enough.
There you go. Good enough for government work?
Never.
Not really, but we're going to take it, right? Now, which side, if I'm measuring like that, which side is the initial side? The bottom one or the top one? The bottom one, right? What if I'm measuring like
It's not a thing, is it?
No, come on. There we go. What if I measure like that? No. How do I do this?
Magic.
I don't like this anymore. Let's get rid of that dang thing. Get rid of this thing. What if I have my, okay, I'm doing it my way. What if I have my protractor like this? Or my protractor like this.
So it's the one against the line in the protractor.
Now which one's the initial side?
The one lining up to the bottom?
The top one. And the, so what am I trying to get through here?
How to use the protractor question?
No, I'm telling you that initial and terminal side depends on your perspective.
Oh, so it doesn't.
It depends on if you got chocolate in the peanut butter or you got peanut butter in the chocolate, right? Caramel or caramel.
Maybe it's Maple.
I want this to go away. I want this to go away. We'll get that out of the way. Okay, so now coterminal angles. Can you stop back after class, Leslie? All right, thanks. Coterminal angles. Coterminal angles are two angles that have the same initial and terminal side. Okay, so let's say this looks 30-ish. That looks 30 degrees. Can somebody think of a coterminal angle for that 30-degree angle? 150.
330.
330.
Because it would start at the same time.
So 330. So 330, Morgan, starts here and goes one and ends right about there.
Okay, so it's 390.
390, right? Because this is 360 and then another 30 would be 390. 390 is a coterminal angle. As is, see, now this was the initial side and this is the terminal side, right? Also, another coterminal angle is that which is negative 330,
I
right?
tried.
Negative 330 is a coterminal angle.
Try.
You did well, Morgan. Now, what about this? How about that? What about negative 30?
It doesn't start at the same time.
Oh, so it's got the same sides, but it doesn't have the same initial side or the same terminal side. They're flip-flopped. These are not coterminal angles. Okay? Now, you don't need to put this in your notes, but a consequence of coterminal angles is the absolute value of one plus the absolute value of the other. It's always going to equal 2 pi. 2 pi. Or the absolute value of one minus the other will always equal 2 pi. Remember what we talked about with that thing? Yeah.
Do we have pi?
Do we have pi? No, we don't have pi. All right, more definitions. Complementary angles add up to be, radian speak,
X over pi over 2.
pi over 2. Supplementary angles add up to be what?
Pi.
Pi. There's your pi, Alex. Supplementary angles. Say again? You can have all the pi you want.
Go to quick trip.
Now, an angle in standard position. It's in standard position if the initial ray corresponds with the positive x-axis. So, I take that angle. Is that in standard position? I say no. Why do I say no? Because doesn't coincide, the initial ray, if it's this, right? The initial ray does not coincide with the positive x-axis. Well, what about if I do that? What I need to do, Morgan, is turn my head a little bit, right?
Or rotate your paper.
You do this in physics. Who's in physics this year? You do this you're doing this right now, aren't you? You're doing this right now, aren't you, Ben? Because if you got a
Is this part of the real life problems we're going to be doing?
absolutely. If you got a, what am I drawing right now? Free body diagram, right? Gravity pulls this way. The normal force pushes that way, and then I'm pushing it up the hill that way, right? So I can either look at it. I do have friction, but we're talking ideal systems, so I don't care about friction. I can either look at it that way, right? Or I can rotate it and look at it. I didn't rotate it far enough. Right there. Or I can rotate it like that. We do this, don't we? We do that because it makes my math easier. So yes, you can do that. Okay. So, okay. We talked about positive and negative angles. Now we're going to get to how to make degrees into radians, how to make radians into degrees. So, you've probably been given two equations in the past. I like to go with one. Okay? And here is the equation. If I have an angle measure in degrees, Sam, and I want to convert it into radians, I plug the angle measure that I have in degrees right here. And then I solve for the angle measure in radians. What do we call this type of relationship? Starts with an R. What are you doing, boy?
Random.
Ends in ratio.
Ratio.
Ratio. It's a ratio.
Ratio.
Think about this. I start at the positive x-axis and I go up 90 degrees, right? Now, how far of the way around a full 360-degree circle is that? 1/4, right? 90 divided by 360 is 1/4. Now think about this. I start at the x-axis, the positive x-axis. I go up to 90 degrees, or I go up to pi over 2. I'm in radian land now, right? I go up to pi over 2. How much of a full circle is that? Pi over 2 divided by 2 pi, right? Is that 1/4? Pi over 2 divided by 2 pi. How do I do that? How do I divide a fraction by? Multiply by the reciprocal. So I go pi over 2 times 1 over 2 pi. Pi's cancel out, right? Then I get 1 times 1 is 1. 2 times 2 is 4. So we see how that works. We just set up a ratio and we solve for our variable. So let's do that. Let's do 30 degrees. Theta is 30 degrees. Let's find the radian measure. Let's find the radian measure. Do we want help with this? It would help if you guys had your notebooks out with blank sheets of paper and we're doing stuff. It would help. Yeah, I know. I'm asking you to do something here. No, we're doing. See, it says, now you try. You know what that means?
You try.
That means you try. We're converting this to radians. We're converting 30 degrees to radians. What's that? What do you mean, what would you want your things in? You want your angle measure in radians. Here.
Does that have a symbol like degrees do?
Showing me small. You want a pencil? I don't like this pen. That's fine. So, how do we do this? What should I write on the left-hand side? I'm gonna put an equal sign in here. What should I put on the left-hand side? 30 over 360. Okay, that's a good place to start. And this is 30 what? 30 chickens? 30 degrees. And this is 360 degrees, right? All right, equals what? What should I put on this side? Bottom of what? Okay. What do I put on the top? R? Let's put theta, since that's what we're finding, right? And then what? How do I get theta by itself? 30 divided by 360 is 1/6. 1/6 times 2 pi. No.
Oh, wait, there's
Pi over 3, right. Pi over 3 equals theta. Pi over 3 equals theta. Now, we get negative 5 pi over 6. Now you got your equal sign. And what goes over here? What goes on the left? Put that there? Yeah, it doesn't matter which side I do, whatever. This could be all degrees over here and all radians over here. But when I'm setting it up, do I mix these? Do I mix degrees with radians? Mix degrees with radians over here? No, it's all degrees or all radians on one side, and then it's all the other one on the other side, right? So what goes on the bottom of this? 2 pi, because that's a whole circle, right? And then, division bar, what goes on the bottom of this one?
360.
Because that's a whole circle, right? 360 degrees, not chickens. And then on the top, theta. Theta. Now, we can either multiply by 360 now or later. I'm going to choose later because I want to make sense of this hot mess. Negative 5 pi over 6 divided by 2 pi. Multiply by the reciprocal, right? So this is negative 5 pi over 6 times the reciprocal of 2 pi is 1 over 2 pi, right? Yes? Pi's cancel. And I get negative 5/12, right? So then I get negative 5/12, and now equals theta over 360 degrees. Now I multiply by 360. And I multiply by 360. Why did I put the parentheses around the... Yeah, not only that, I don't want it to look like 360 minus 5/12. Because then I might do the subtraction. And is that going to give me the right answer? No. No. So now, I'm going to do this. 360 into 12. Well, actually, 12 into 360. How many times? 30. Right. So 30 times negative 5? Chickens? Degrees equals theta. Bam. Right? Next page. Next page. Now, sometimes when we measure in degrees, how many times have you guys seen 26.7215 degrees? We don't see fractions or decimals of a degree too often, do we? What we do, especially when we're on Google Maps, is we do degree, minute, second notation. Forevermore known as, I'm going to call it DMS notation, because I'm lazy. Okay? So when you see DMS, you're going to think, oh, degrees, minutes, seconds. Okay. So, when I want to know the latitude and longitude of Somerset, Wisconsin, I look on Google Maps. Okay? And Google Maps tells me that Somerset is at 45 degrees, 7 minutes, 27 seconds north latitude, and 92 degrees, 40 minutes, 24 seconds west longitude. What does that mean? When I say 45 degrees north of what? The equator, right? So, the morning class laughed when I did this, but you got the equator right here, right? You know where I'm going with this. And you go up 45 degrees.
You really set yourself up for this.
You could just dump on a rock hand, then it would
All right, so this is 45 degrees, right, from the equator. What about this 92 degrees, 40 minutes? What about that? What's from what?
It's called the line that goes down. I don't know what it's called.
Where does it go down?
The middle of the thing, like
The middle of the thing.
Okay, so we have the equator that cuts the Earth.
What's the middle of a ball?
The center poles that goes from the poles of the sphere. The outer. What is
Well,
it called?
I mean, I could draw a line through the axis anywhere I wanted to on that globe. There are two important up and down lines on
It's the
the.
prime meridian.
The prime meridian is one. What's the other one? What's it? International Date Line.
Why?
So the prime meridian goes through Greenwich, England. Okay?
Greenwich?
Greenwich, England.
Greenwich?
That is 0 degrees from the prime meridian, meaning the prime meridian passes through Greenwich, England. Prime meridian.
Prime meridian?
Now, from the prime meridian, we go 92 degrees west. Which way is west?
That way.
That way, well, from my perspective, it's, from your perspective, yeah, that's west. Go west around to, so we are a quarter of the way around the Earth from Greenwich, England. Okay, so we go from the equator, we go up 45 degrees, and then we go 90 degrees west from Greenwich, England. And that's where Somerset is. Okay? But we can also do relative angle measures. Case in point, Somerset is 47 degrees, 26 minutes, 15 seconds west of north from Hammond, Wisconsin.
West of north?
West of north. Here's what it means. If I'm sitting in Hammond, Wisconsin, I want to know what direction is Somerset. I can go that way, or I could say northwest, but northwest might be like somewhere in there, right? But if I want to be exact, are you laughing at me again, Hannah? You are laughing at me. So it could be somewhere in there. But if I want to be exact, I go 45 minutes, 45 degrees, 7 minutes, 27 seconds. Now, west of north. So I take north, right, which is that way, and then I go 45 minutes towards the west direction, or 45 degrees from the west, or from north. So I go in the west direction from north. And that's what this means. Okay? Clear as mud. We're going to have a lot of word problems that look like this.
Clear as Kool-Aid, man.
We're going to have a lot of word problems that look like this. So, now I want to convert from degrees, minutes, seconds to just straight degrees and vice versa. Check this out. We do 60 degrees, or I'm sorry, 360 degrees in a circle, right? We do 60 minutes per degree. And we do 60 seconds per minute. We get this from the Babylonians. The Babylonians were on a base 60 number system. Base 60 number system.
Yeah.
What base number system are we on?
10.
Base 10. Base 10, meaning I got 10 digits, right? I got 0 through 9. And then, once I get to 10, I add a placeholder, and then I go from 0 through 9 in the next placeholder again, right? I do that all over again. Why do we have a 10-digit number system? Why?
Easy.
Why is it easy? What's our first experience with math when we're little turds? No, before that. How many sheets of paper do I have? What do I do? What's the act of figuring out how many sheets of paper I have in my hands? What do we call that act? Counting. This is counting, right? Why do we have base 10 number system? Because what helps us count, Kristen?
Over 10 fingers.
Fingers. Got 10. Well, actually, we got 8 fingers. We got 8 fingers, but 10 phalanges. 10 phalanges, right? So, I riddle me this, Batman. How do we count base 60? How did the Babylonians do it? They counted their knuckles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 12 more would be 36. 12 more would be 48. 12 more would be 60. This is 60. High five. Right? That's how they counted. That's pretty cool, huh? So if you ever has anybody ever gone and was doing counting on their fingers and said, I'm at 11, now what do I do? You do toes. So you take your shoes off.
Yeah.
What about if you wanted to count past 20?
You get
more
people to help you.
You restart, or you just count like the Babylonians did.
Or you get more people.
Anyhow, now let me ask you this. Back to this. If I want to convert this straight to degrees, not degrees, minutes, seconds, but just degrees. 23 seconds is what fraction of a degree? Or not a fraction of a degree, fraction of a minute. 23 over 60, because there are 60 seconds in a minute. Good. So this is 38 degrees, 48 and 23 sixtieths of a minute. And then I figured that out in decimal form. That is probably 383 repeating. 0.383.
Yep.
So then it's 48.383, 38 degrees, 48.383 minutes. Now, how do I find the degrees? How many degrees is 48.383 repeating minutes? You take that and you divide it by what? 60. Why?
Watch some numbers.
60 minutes.
60 minutes in a degree, right? So now you do this, and you're going to probably get 0.81, 0.801, 0.81. So that's 38.81 degrees. Do we see how we did that?
No.
Come see me after class. I'm going to skip the convert to radians because I really want to get to this. I want to go back now. I want to go from this hot mess into degrees, minutes, and seconds. So, remember, I got 86 degrees, right? How do I find the number of minutes? I take the decimal here, the 0.48319, and do what to it? Yeah, I divided by 60 before. Now I got to do the inverse operation of dividing by 60 and do what? Multiply by?
60.
Multiply by 60. So this would be 0.48319 times 60 minutes. And yeah, it's going to be like 27 or 28 minutes, right? But it's not going to be a whole number. It's going to be 28 point something, 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 right? So this is 86 degrees. How many? 28.9914 minutes. Now I do the same thing with this 0.9914. How many seconds is this? Well, this is 28 minutes, 86 degrees, 28 minutes, and then it's 0.9914 times 60 seconds. Yeah, that's going to be 58 or 59, right? So this is 86 degrees, 28 minutes, 59 seconds, or 59 point something?
59.484.
484 seconds. That's just the units they have for seconds, the units they have for minutes, and the units they have for degrees. That's how we signify. Okay? Practice set. Shouldn't take too long. So we're jumping into another lesson tomorrow.